Okay, then I guess I can start. Welcome, everyone. My name is Xiao Shi, and I'm going to present the lights on Apex side, and my colleague will represent in the United States side. So I will just briefly introduce myself. I have joined Configura for 3 years, and I am a production developer. Mainly do customized extension for China and US customers. So yeah, we can just go to our agenda here. So about lights, we're gonna to talk about what is light, and then we're gonna to talk a bit more on how we should write our own light snappers, and then how we can add light settings to our light snappers. And then we're going to touch a little bit of physical light, which is a new thing in 12.0. And during my presentation, if you have anything, you can either type in QA and Marna will be helping me out, concentrate on that, or you can just raise your hand to interrupt me. Yeah. So what is light in CET? I think for developers, or let's say customized extension developers, will really touch light actually. For me myself, I rarely use lights. I think just for maybe just in CET training. But here actually we have plenty of lights accessories in CET. You can see that here is a extension called 3D extension. This is a basic extension. And here you have a light sections. You have 4 lights here, and you have some related toggle function here. And also we have a light extension by itself. It's an util extension that you can download freely through my Configura. And you can see that here are a bunch of light products inside it. I think for designers, they often use that for rendering effects. So if you're interested, you can just get the extension and play around with that as well. So that's all basically the lights in CT, but what is light in code? Actually, if you enter into snapper.cm, you can see that there are actually a bunch of light-related interfaces, but you can see that it's do nothing, basically, because if you have your own light snappers, you'll need to handle that by yourself. So let's take a glance of the structure here in CM. We have snapper as the parent class. We have something called basicLight.cm, which is a parent class for the light extension. It has like amount of child snappers extending from that, but that one is the basic light snappers. And here we have 4 snappers that are actually 4 lights in 3D extension. And you can see that it's just a sublin of the basic lights and extends from snapper directly. We also have customized light snappers. So I know that some of our customers have their own lights or want to have some light behavior product. So they can extend from snapper and make their own lights. And you probably wonder, what is this light 3D array that I put for every light snappers? Or basically, this one is, it's actually, we'll see that here you have in snapper.cm a method that return this light 3D. So if you have your own lights, you need to fill in some light 3D and return it. And this light 3D is a type of 3D, but it's not for you to look at it's a 3D that's simulating the light behaviors. So talking about light 3D, we have several types of light 3D. I just briefly listed something that you should be more interested in. So this one is called Omni Light 3D. And for that one, it's just like a point that emitting light equally in every direction. So you can imagine a light bulb in real life, which is basically the same behavior. We also have something called Spotlight 3D. So this one is emitting a light and focus it at one certain target. I think the name itself is pretty self-explaining. So it's just like a spotlight in real life. And you can define, apart from the OmniLight 3D, you can also define the shooting angles and the cone width and so on and so forth. We also have something called Physical Light 3D, which is a new stuff that will be in 12.0. I will leave this for later of this session. So we're a little bit concentrate first on the existing Light 3D. Here are just pictures of things that I just talked about. Like this one is just an Omni Light example in real life. So you can see that it's shooting everywhere. And this one is a spotlight. It's just, I think you're probably familiar about the spotlight snapper and extension 3D. Things that it plays it and it can set a target. So this light will have a shoot out of a concentrated light and shoot for that target. So yeah, that's basically the light 3D. And we're probably wondering that if we already exist those, how and when I need to write my own light snappers. Well, in cases that if your company has, or your customer that has its own their own light accessories, or they have like embedded light for their sofa or their desk or their shelf, then they want to have the light effects. So you need to write your own light snapper product. So how we turn the regular snapper into a light snapper? Simple as it is, I just need to override this two method. One is called deny lights, and naturally you don't want to deny lights, so you return false. And then you just create some light 3D, pass it into a light 3D array, and just return it. And actually this piece of code is in the conference Spring Lights code. And also, let me show you here. Maybe, how do I stop it? Let me show you a little bit. So, oops. So this is the CET conference, and I have a lights demo session here. I have my all the code, example code are actually here. So you can just play around with it if you want to check it out. So the piece of code I just showed is in the simple light, and it's just or turn into a light itself. Yeah, just mention about that. Okay, let's go back to the PPT. So with that two method, it will just become a light, and when you render, you will see it will shooting light. Or if you turn on the real light, it will actually shooting light by itself. But then you probably wonder that if I want to some way control my light, like for example, if you buy some lights in real life, you probably want to have the light of different temperatures. Like here, if you want to have, like for bedroom, you want some yellowish light, and for your office, you want it to be more bluish. Then, like this one, it's the same light, but it has different, we call it temperatures, and you have different modes at render. Or that if you want to have it be more concentrated or less concentrated, or if you want it to be more bright or less bright, then we call that light settings. And I think in most of cases, you want to have some way to control your light, right? So let's take a simple example of the temperature here that we just talked about, and we're going to try to teach you how to add light temperatures into the light that you just created. Or in normal cases, you probably just want to have that temperature stored in your quick property, and then you toggle the quick property, and they reflect in as a light itself. But just imagine that if you have a very big conference room and you have, like, let's say 50 ceiling lights, and for designer, when they render, they probably need to adjust the light so many times so to see what the render effect comes out best. Then you won't want to click every single snappers just to adjust its quick property one by one. So, okay, I'll talk about how CET will do that by grouping it and not grouping it through a dialog called light setting dialog. Okay, so back to this. What I just missed is actually in code, we don't use this temperature because this one is a double. But for 3D, for this one, you don't really see any double that you can control it. And it actually different in color. So by code, we have a helper method that can turn the temperature into the RGB color and just apply that to a light 3D. I will show you the code in when we touch the temperature session. But for now, I just introduce this light setting dialog that I just talked about. So the dialog here is like a alternative of the quick property that can allow you to bind or unbind your snapper into a light group and can change it all at once. So you can see here, it has so many different properties. And if you bind correctly for a group of snappers, then you toggle the brightness, it will change all at once. Okay, so let's just do a quick demo for that. Okay, I've already opened it. So you can see that I have 4 different snappers here. These 2 are spotlights, and these 2 are called ball light. And you can pull out the light setting dialog through here or through here as well. So, okay. So actually, let me set back. When you select initial stage, when you select a light snapper, it will come out with a light name and for the light group. And the dialog will expose the light settings that you can adjust for this light. So if I turn on my real time, it's kind of brightness, but you will see some difference, I hope. If you toggle the temperature, you can see that the light turn into a red or a blue. Or if you toggle the brightness, it will see more of a more bright or less bright here. Well, you can see that I just changed this one. So how can we group them all together? Well, you can just multi-select them and just change them to this one of this. This will call a light group, a global light group. So if you bind them to one group, you can see that it popping up more settings because it will take all of the selection and expose the union of all the selections. Like here, you can see this spotlight, which is only the settings for this two and not for this. So right now, if you, let's say, change the brightness, you see all of them are changed all at once. But if you change this one, you can see that only, for sure that only the spotlight that has this settings and it will change this too, and this too won't get affected. And then if you want to only select, if you want to only change this one, let's say, after you bind this, you just go back to the node group, and then you can control only this one. Yeah. So this is the function of the light settings dialog. And let's go back to the PPT. Yeah, so I actually just show you, actually, I would say that like two different modes. Remember that if you change to this node group and change the properties below it, only the selected snapper, light snapper, will get affected. But if you bind it to either one of these below and you change it, it will change the whole group. So we'll call this light group a personal mode light group, and this one is a global mode light group. And just take notice of this two, and these two are kind of different in the code and in the idea. Before we touch that, let's talk about that. Imagine that if you have to change the settings and pop up to a dialog, you probably don't want to set all the light settings inside your snapper, because otherwise how are you gonna change a group of them together? So you need a third-party class to store all these light settings, and your snapper just simply say, hey, the third-party class just give me what temperature I am or what brightness I am. Or if I want to set it back, I just go to the third-party class and set it back inside of that class. So what is that class? Or naturally, it's called light group. And you can see that there has a comment saying that the common light group, which is what I just mentioned, the global light group that you can change for all the lights, for the group of light, are actually stored in space. And the light group that you only change yourself, let's call that personal mode light group, are stored in every snapper itself. So you can see that there are some labeling keys for the UI, and a little bit more concentrate on this gprop array. I think maybe some of you have touched the props. That is something that you store your properties, your domain, your value, and some UI related stuff, so that the quick property will take from that and build the property for you. So this one is serving the similar idea. It will store the properties inside of it and some UI related stuff. So the light setting dialog will go to this props and just create it based on this. Okay, So in Snapper, it actually have a method called light group, and that is the way that your own Snapper will reach this third-party class to get the light settings. And this one is in snapper.cm, and it's a final one. Unfortunately, can't override it. And let's see a little bit of this logic. So here, if you're not denied lights, you'll naturally go down. And here, this piece of chunk, I will call this, it will try to search the global mode light group. If it can get a light group key, which is a key pointer, and get that key to search that inside a space and to try to get the global mode light group. If you have anything, found it, then just return that. If not, you will fall into the personal mode group, which is controlled here, called individual light settings. But in snapper.cm, the light group key method and the individual light settings are empty, so it's doing nothing. So if you want to do your own light group binding, you need to do some few steps. Let's talk about one by one. The first step is that you need to maintain your key and your personal mode light group by yourself. You just store them as fields, and you need to override the light group key. Simply return the key that you stored, and in the individual light settings, you just check if you have a personal key, return it. If you don't, you need to set it up. We can ignore this init or repair for now, but I will present that later. But for now, it's just for you to initialize your own personal mode light group. And once you set this up, and if you open the light setting dialog, you click your own light snappers, it will actually show the light name and the known group, which means that it actually finds that you have a personal light group. But there's empty light settings here because we haven't set anything. So yeah, let's get started to add some light settings. Remember that we mentioned a little bit of the temperature, and it's time that we add this into the light setting dialog. Okay, so first of all, you need to set up a temperature method. And notice that in this temperature method, you actually not store the temperature value inside your snapper. You get the light group and ask for the temperature by this one. And then you will have some color method, and this has a helper method to turn the temperature into a RGB color. And then when you return your light 3D, you assign this light color. And here's a parameter that you can assign to, which is called color. So you just assign this to the color, and you will successfully bind the temperature to your light 3D. And then, hopefully you still remember the init or repair method. That one is where that you actually set the temperature inside your light group. So inside of it, it will call g.repair, G is a light group, and it will pass in some key label value, which is default value, and some domain. And if you go inside of the repair method, it is actually just taken out the prop that's stored in the light group itself, set it up if you cannot find it, or just update it. And if you have successfully set the gprop into your light group, then if you try to open up again of your light settings and you click the light box that you have added, and you can see that the temperature is here. Because this temperature is uniquely defined, so it will fall naturally into a color section. And because the domain, we define that as a slide domain, so it will do, the dialog will know how to build it. This is pretty similar of the way that you do the quick property. So, okay, so you actually successfully exposing your light settings. But right now, if you slide this, nothing will change. Why? Because you didn't do the update yet. So you need to do the updates, and when you change anything in the light group dialog, it will call light group changed, and it will pass in a key and a value. So the key is temperature, and the value is, we will cast it to a double, and it's the new value that you changed to. And you will just check, if the key is the temperature, then we need to invalidate the light 3D. Yeah, and then after you do this changed, when you change this again, let me be able to play this video. Yep, and if you open up the real-time light and you change it, it will change. So, okay, so before step 4, you have successfully built up your personal light group. But if you want to bind it, you still need to do a bit of few steps. So here, this set light step, set light group, sorry, is where you call when you change the light group in your dropdown, and you are passed in whatever light group you have selected, and call the set group. And here you need to check your light group key and bind it to your own light group key. And if it passes in the personal mode light group, the key is now, then your light group key will be now. And then remember, in the snapper light group, it will just fall to the personal mode. Okay, so beside this one, you have to do one more step here. If you have already bind few members in the global mode key, and you want to add a new member, but the new member's temperature, let's say the temperature, is the value is different from the existing members, then you have to synchronize them. So one more call that you have to do a little bit is the sync to light group, which is happened when you bind a new group to the existing ones, and it will call to the snappers, i.e. the new members. And then you need to do the init or repair so that the light group will update the gprop inside of it and synchronize yourself to the other members. Yep, and then up to now, you successfully set up your light group, and now your light box will behave the same as the lights in CET. But there's one more simple things that you need to do, is that you need to, not you have to, but it's a simple way that you have this light settings pop up built into your quick property. So you just do this. I think this one might be more familiar to you. So you add a quick property, and then you have a callback to show the dialog when you hit this button. And then that's it. You have set up your own light snappers and bind that correctly to a light group function. Yes, a little reminder for the light settings. Remember that when we bind a spotlight to, or maybe I can just bring back to the CET. Remember that if I toggle it to L1, this spotlight actually only affect to this two that has this key value pair. So if you want to share all these properties, make sure that you have the same key. So if you want to have your own properties, like you have your own temperature that don't want to share with any other lights, then you have to assign it a unique key. Then it will go to another column, another row. And if you change that, it will only affect the light snappers that you define and not any other light snappers. So a bit concentrate on those. Yeah. And then let's go back to the slide. If you want to have more information, there is extensive examples in the light extension snappers. They have much more complicated settings built in there. And also, there's a great article in the Help Center that basically taking the spotlight snapper and introduce you about how to write the snappers to use the light groups. So you can check that out as well. Any questions so far?
So far, no. No
Okay.
questions or any raising hands either.
Okay. Okay. Then I will continue about a new light. So, physical light. The physical light is a new type of light, I should say, that come in 12.0, and this is a render picture using the physical light. So I, well, personally, my feeling is that, well, the big differences from the vision is that now you can see the image itself is glooming out, emanating out of lights, and also like the light here and the light here. The lamp itself are actually also emanating light, so you can see that this one is bright, this one is bright. But before that, the light that we have now doesn't just have the light shooting out. Like we can see this, but we don't really see this. So yeah.
I have a question.
Yeah, sure.
For the rendering just now, was it rendered using the normal setting to have this effect? Or do you have to have a special preset to achieve this effect for physical lights?
I think, or this actually not rendered by me, it's rendered by our render expert. But I think that this the render method is basically the same, but it's just using the physical light instead of the OmniLight or Spotlight 3D that we used to have.
All right. Thanks.
So about physical light 3D, remember that in initial light, way before, we talked about different light 3D, and I didn't mention this one, and now I will mention it. So this physical light 3D is also extend from light 3D, but it has a node, which is a sim node. You can find that, check it out in, well, this one will come in 12.0, and now it's in a project branch. So if you want to check it out, I also mark it in the DEFRA conference extension it has a label redirecting the branch that you can enter to check this out. So this physical light is one type of light 3D, and how we're gonna write that? Simply enough, you still need to write something in the get lights, but instead of the Omni light or Spotlight 3D that we just mentioned about, you will create something called physical light 3D. And what it do is that it will take a CM sim node, and the sim node will pass in a sim mesh light, which I will cover in a minute. So it will pass in a sim mesh light, and then you will define a physical light 3D, assign this node, which is here, assign this node to this sim node, and just return this light. Set as not complicated. So what is the sim mesh light? Okay, let's talk about this. The sim mesh light is a subclass of the sim light. The sim light extends from sim component, and inside of it, it has some settings, light settings. So instead of controlling the settings in the light 3D, you will control the settings here in the sim light. So I actually have some different types of sim light. This one is called a sim point light. This one we're just defining a point and also shooting out the light. It's more like the Omni light 3D that I just mentioned. And this is the sim mesh light, which will take the mesh and turn that into light. I will introduce that a little bit more in the next slide. And also we have the sim spotlight. This one is more like the spotlight 3D that I just present. So when you have a sim light, or let's say a sim mesh light, you can see that we pass in a whole bunch of parameters here. The color data is just a color that you can pass in a color, or we can have other helper function. You can pass in a still the temperature, like the way that we did before. And this power is define the brightness of the light. Here we are using the lumens, which is how you determine light brightness in real life, or you can just define some double there. So it will be helpful method to transfer different type of how to say figures into the power light power. You have this IES file path that you can pass in some file called IES, which I will show you a bit later as well. This IES file is a way to control how your light is attenuate and how your light affect how the shadow looks like. Yeah, things like that. The use materials is that if you use materials to be true, then it will overwrite the color data. So if you apply a red material, it will overwrite this color data and show it more red. This visible mesh, it will define that if you, because this one is created by a mesh, but when it has the light, the mesh is still there. So you probably want to hide the mesh. Sometimes you don't want to see the real light ball, you just want to see a light coming out of it. Then you need to set it to be false to not see it. The double-sided is actually a property for method and for mesh, sorry. And this is a picture of mesh, how a mesh works that I take from Wiki. So you can see that this dolphin is a 3D model, and in CET, we actually split it up into little triangles, and one of these triangles we'll call a mesh. And if you want to have more detail, then you have more triangles. If less detail, then less triangles. So this mesh light will take each triangles and turn that into a light. So every single little triangle will emitting light by itself. And this double-sided means that inside of this model, it's actually hollow. And this mesh inside is also another side. So if you want to have that double-sided, then inside of this mesh, the inside of this whole model, we're also shooting out light. But if you are a closed model like this dolphin, you probably don't want to have the light inside of it because no one will really see it. So usually we'll just have that set to false. And this on is just light turn on and off. And you can control that by light settings and pass it in. But here I just set it to be true. So that's pretty much of the parameters. And here is actually the IES file that I just mentioned. Before in the OmniLight 3D and the Spotlight 3D, we can control the shadow by the code, but that doesn't turn out very nice. So right now, we offer the opportunity to pass in this IES file, and these are some of the preview of the IES file, and this will be how your light will looks like. And this IES file is a standard format file. You can download that online, or in Model Lab in 12.0, we also have some pre-installed IES file that you can select through the Model Lab, or you can download them and just pass the URL into here. So yeah, this is the IES files. So for the physical light, another difference is that you can actually turn your model, the whole model, into a light itself. So I actually built this sim shade box, which is just the box that you show in the 3D. You can turn the whole box into a light. So this is a way that you can do that. You just define a box that is the same size using the same node. Another way to do that is if you have ever done the CM-Sim way, if you go to the build sim and not to the build 3D and build 2D, then the snapper actually won't go to the get lights here. So in this way, in the build sim, you just pass in the sim spotlight in the same node that you want to get the light effect, and you just pass it here. So about CM-Sim, I think that's another giant topics, and I'm not an expert for that. So I think you can see more in the migration guide. This has related topics about the physical light itself. There is also another way provided that you can add a light in the Model Lab. I think this is more for catalog expert or designers. Then you can just select the model itself or any layer that you want to turn it into a light. Then you just hit the Add Light button. Here is the way that you can control the colors. You use materials or temperature or color itself. You can control the brightness. And here is the LM is the lumens. And then you can also pass in the IS file. And if you hit here, we'll have a drop down of CET built-in IS files. Choose one and apply. Otherwise, you don't need to apply as well. And all this will also show up in the light setting dialog itself. So if you finish your light, you can still change your light settings in CET itself. And after you've done that, you can save the file and drag that into CET, and it will turn into a light itself. Yeah, simple as it is. If you want to know more about physical light, there's an article there already in the migration guide, and also you are always free to contact the developer support if you have any question about the physical light. And yep, I think that is the end of my presentation. Any questions?
Thank you, Xiao. We do have one question. The
Yep.
question is, will there be ready-made light objects that designers can use directly, which allows the same
Ready-made.
customization? Yeah.
I think that for now, as far as I know, there are not a custom already made lamp, because for customers, let's say if you want to have storage that has light inside of it, right? Then you just need to turn your shelf into a light snapper, and you just pass in the light effect inside of that. So you don't really need a light snapper to be override. You just override your storage snapper. And then you have the fully control of deciding how the light affects inside of your storage, meaning that if you want to have the light shooting out from the top of the storage, you can just decide, just pass in the position of the light 3D. Yeah, things like that.
I think maybe what Jerome meant was, would there be any light objects inside CT Designer that implements physical light directly?
Oh, for the physical light, you mean?
I think so. Yeah. And I think
For
for that, the plan for 12.0 is to convert most lights within CT Designer to physical lights. So if everything goes well with the release, then I think that you can pull out a spotlight and it will actually be a physical light. This kind of like a, yep, that's what I meant. Yep. Then you can refer to those lights as an example if you want to implement your own.
right, okay. This is a question. Okay, so I think for 12.0, all the lights in CT will turn into the physical light itself. So I think there is plenty of examples there. And I've seen that there are also helper method to let you easier to turn into your Omni Light 3D into a physical Light 3D. But yes, I think the goal for 12.0 is to, if you ever overwrite your own light snappers, you need to use the physical Light 3D. But yeah, again, I think there are plenty of examples there in the light extension, so you can just refer that